Hi everyone, today my team and myself. Now that's too formal, right? Okay, let's talk on how Pipo 3-bit was built and what is shift register generally. Okay, let's start. First of all, do you guys really know what is shift register? A shift register is one of the type of digital circuit where it will use a cascade of flip-flop. The output of each flip-flop will be connected to the input of next flip-flop and they share a single clock only. Because of that, the stored data will shift from one location to another location. Now I think you guys got it from where the word shift in the shift register came from. Basically, several single D-type data latches brought up in serial type daisy chain arrangement together, either 0 or 1 logic to form a shift register. Not only that, shift register consists of both parallel and serial inputs and outputs, which are often called serial in, parallel out, which is known as Pipo, or parallel in, serial out, PISO. Shift registers are also bidirectional, which allows the process to be done in both directions, left to right or right to left, and it also known as circular shift register. Guys, over here. There's an important note here. Take note, yeah. Do you know, since the individual data latches are driven by a common clock, it can be also stated as a synchronous device.
Hello everyone, today I will show the demonstration of parallel input parallel output, which is known as Pipo with 3 bits using Xilinx ISE 14.7. First and foremost, click on the new project and then give a name for the new project. In this case, I will name as Pipo 3-bit, and I would like to locate this file at ISE musics, and here I will locate the file in music. Then click next and go to the evolution development board. Press vertex ML605 and then click next and finish. After that, go to hierarchy on XC6VL, right click on that, press new source and press Verilog module, give a name for that. So in this case, I will give a name as a Pipo 3B and click next and finish. In this step, we will be doing the behavioral type of coding. First of all, we will write the constant that we are going to use as input and output. Then declare the input and output. The value in square bracket is represent the number of bits. In our case, 2 to 0 means 3 bits. Then start the coding with initiating clock as a positive edge. After that, we need to write the operation of the Pipo shift register. In Pipo shift register, the input simply transfer to output. Therefore, we assign B of 2 is equal to A of 2. This same function will go to B of 1 and B of 0. After finish the code, check the code whether got any error by simply press check syntax in synthesize XSD. Since our code is correct, now we go for the test bench. After checking the syntax, go to hierarchy and right click on the Pipo 3-bit, add new source and click on Verilog test fixture and give it a name. press next, next, finish. This is test bench code. So we're gonna add a code that generate clock. Then we're gonna add the input to the Pipo shift register. After we create the input for the Pipo, we go to the simulation and press Pipo 3-bit, then press iSim simulator and then double click on the behavioral check syntax. When there is no error in the Pipo shift register test bench, we can simulate the behavioral model to see the waveform of the input and output by simply double click on the simulate behavioral model. As you see, this is the waveform of Pipo shift register. So I input the value on after 100 nanosecond. So there is the 100. Since it will read on the positive edge of clock, so the output is shown at the positive edge of the clock. So as you can see, the output also 100. Same goes for the second part of the input where we put 101 and the positive edge of the clock is given as a 101. This is sure that this code is functioned properly. There are two modifications can be made in this behavioral type of coding, which are simplifying the operation code and increasing and decreasing the number of bits. First, we're gonna see how to simplify this code. As you see in this three code, it can be represented as a B equals to A. So each input, which means A1 and A2, A0 will transfer to the B1, B2 and B0 automatically. By simplifying this code, it can reduce the complexity of the code and reduce the time usage. The second modification can be made is increasing and decreasing the number of bits. To increase and decrease the number of bits, we can simply add the parameter. For example, to increase the number of bits, by this we can increase and decrease the number of bits by simply replace the number in parameter n equals to 4.
Now, let's have a look at the frequently asked questions, also known as FAQ, which means the common questions tend to recur about this project. Question number 1. What is the meaning of square bracketed 20 in the Verilog coding? The square bracketed 20 simply defines the constant contains 3 bits. Question number 2. What is the hashtag number in test bench code means? This literally means the period of delay for the next code to appear in the waveform. For example, based on the project just now, the wavelength starts after 100 nanoseconds. Question number 3. Why we insert less than equals to instead of equals to in Verilog module? Less than equals to represents the non-blocking assignment. There are two types of assignments in the logical operation, which are blocking assignment and non-blocking assignment. Blocking assignment always used for combinational logic, whereas non-blocking assignment is used for sequential logic. Besides, Pipo is a sequential logic, therefore non-blocking assignment is used to describe the operation. Question number 4. What is the meaning of always lies post HCLK in the Verilog code? The always statement is to elaborate the logical operation under a certain condition. Therefore, always lies post HCLK is to run the operation when the clock is rising. Question number 5. Can we insert the 4-bit of binary into the input? Absolutely cannot, because we declare the input as 3-bit only in the previous code. And the last question will be, what are the applications of Pipo? Parallel in, parallel out can be used for data transfer, temporary data storage, and also multiplication. That's all for frequently asked questions.
Last but not least, shift registers has their own specialties which makes the workload to be reduced. Shift registers is a very quick process compared to normal converter circuits where it can convert data from serial to parallel or parallel to serial very fast. Moreover, they look simple in design, so it can easily rig up a circuit to create a shift register model, and it can be also used to encrypt or decrypt data. At the same time, some features like the strength of the output current flows out from a shift register is not too powerful, and the problem will be corrected in the future to make a better change in future science generation. Thank you.